milliliters of 0.22 molar sodium hydroxide. When you see the word neutralize, what that means is it's going to move both the acid and the base levels to a neutral level, which most of us are familiar with as a pH of 7. So how does one set this up? Well, what we know is that M1 V1 is equal to M2 V2. Now, in this situation, this is the acid value. This is the base value. You could switch the base to here and the acid to here, but this is what it's saying is that the concentrations and the amounts here of the acid are going to have to match what they are over here at the base. So with that idea in mind, it's really just a matter of plug and chug, in which you have a concentration of 0.25 is in fact the concentration of the H plus hydrochloric acid, and it's asking you for what is the volume of that amount that is needed so that the concentration of the hydroxide, which is 0.22 times the volume of that hydroxide, which is 435. What it's asking you is to figure out the proper amount volume of this concentrated hydrochloric acid so that when you mix it with this concentration, this amount of base, that the two are going to achieve a neutral or a pH of 7. So when you do this, you simply crunch your numbers, and the volume is going to be 382.8 milliliters. So this is the volume of hydrochloric acid, which is at a 0.25 molar concentration. That's the amount that needs to be added to neutralize or bring to a neutral value this much base. Okay, number 3. Is the hydroxide ion concentration in a solution with a pH of H.2. Okay, the hydroxide concentration is the concentration, try it again, what is the hydroxide ion concentration in a solution with a pH of 8.2? Hydroxide is equal to the OH minus. So what it's asking us for is the following. If you know the pH value you're going to need to find out what the H plus concentration is, and from that calculate the OH minus concentration. Once again, you're looking at a two-step process, step A and step B. Let's take a look at step A. So when you go from the pH to the concentration of the H plus, the equation says that the H plus concentration is equal to the inverse log of the negative pH. So, when you place this value here, then your concentration of your H plus will give you a value of 6.3 times 10 to the minus 9. That fulfills the first step to get to here. Now, this concentration of H plus has to undergo a relationship to the OH minus. That is going to be step B. The equation says that the H plus times the OH minus is going to equal to 1 times 10 to the minus 14. That is the dissociation, or the breakdown of the water into the H plus and OH minus value. So now what we do is we're going to fill in so that the OH minus is equal to 1 times 10 to the minus 14. And down here we're going to plug in this value to here, and it's going to be 6.3 times 10 to the minus 9th. Again, the suggestion is to calculate this. Is you first have 1 divided by 6.3. When you do that, you get 0.16. Then you deal with the exponential, in which you get 10 to the minus 14th minus a negative 10 to the minus 9, which will give you 10 to the minus 5th. Now, to change this into full scientific notation, you're going to move this over 1. You'll get 1.6. That would be times 10 to the minus 6th. And that would be your answer.